Okay, this is day number 7, unit 1. This has your warm up, this first chunk, and then after that, down here starts your assignment for today. So some more practice on graphing calculator. So let's try the warm up first. Pause the video, try the problems. There's a little area right here for you to sketch your pictures if you're doing anything, and make sure your answers are 3 decimal accurate. Okay, so pause the video and try it. Okay, so I'm assuming you've tried them now, so you can check first. These are the answers. So you can check those. Pause the video if you need to look at them a little longer. This is what you should have got. And now we will do them together. So So first thing, let's see, you might go ahead and enter these equations into your Y menu. Got to change it back to function mode after going over the homework. So math, num, ABS, on my calculator is how I get absolute values. E to the x minus 5, close the absolute values, and the other one is just a horizontal line. 3, y equals 3. Okay. Now, I don't know if we need to graph these yet, but we could just go in and use the table for these. We could go second table. Now, there might be some values from before. So we press 2. There you go. You have 2.389. Rounded or truncated, it's the same. So that's your answer there using table. So remember, second graph button is how you get to the table on these TIs. So whatever calculator you're using, right? Or you could do it from the graph. You could do second trace calc and use option number 1 value. So I guess I'll show you that real quick. And now for that, you probably want to get graph. So let's go to the window and say, well, I don't know, we could just say -5 to 5, -5 to 5, just start off with, and then change it. I don't know, looks all right. I mean, we could go, I think we could go, we don't have to go down so much. So we could, and we could probably do -4 and then -1, and then we could say like 10 or something. So there's the absolute value graph, which you can start to realize absolute value graphs usually have some really sharp points on them. They're not V graphs anymore unless it's a linear function inside. So we could sketch this. Looks like that, and like that. So this is gx equals 3, and this is fx equals absolute value of e to the x minus 5. So I find it helpful to just label these graphs, just help me keep track them a little easier. Now, you might notice in the table there's actually another column now. So the table will give you all the values of all the functions you have active on your Y menu. Now, f1 minus g1, there's a couple ways to do that. You could say, okay, well, let's plug 1 in, and then f1 is this value, 2.281718 minus g1 was the 3 value. And then you could do that on your home screen, right? You could go back to your home screen and do the calculation. 2.281718 minus 3, -0.718282. So your answer is -0.718. Rounded truncated comes out the same. Now wait to round truncated to 3 decimals till you're done. Another creative way to do this is you go to Y menu and say, okay, well, this is essentially like a new function. We could do f1, which was vars y vars function y1 minus vars y vars function y2. And I could create a new function that is this combination. Then I could go to the table and go plug 1 in and go keep going over, and there's the answer, right? Same answer we got. So anyways, just I want you to try different things, get used to doing things different ways. Sometimes one way might just be way better, and sometimes the other way might be way better. Coordinates of the intersections. Now I'm going to go back, and I don't want this graph to show up on my graph, so I'm going to turn it off, or you could delete it. But we can turn it off. Maybe we'll use it later on. Go back to the graph, and then I'm going to find the intersections. Option number 5, intersect. First curve, second curve, guess. My cursor was really close to where I wanted to guess. Now I'm going to put this, let's label this graph. We might use these answers for something else later on also, so it might be helpful to not have to recalculate these. Second calculate, number 5, intersect, first curve, second curve, and this one's around 2. It's quicker to just type something in than to move that cursor over, but you could do that way if you want. All right, so it's not enough to know how to do these on a calculator. You've got to be quick so you can get them done in time on a test. So the coordinates of the intersections are 0.693, comma 3. We can put 0.000 if you want, just to communicate that you're intending to give 3 decimal accuracy, even though it came out to exactly 3. And no union. This is not interval notation. These are coordinate pairs. These are ordered pairs. 2.7094, comma 3.000. So that seems good enough. These are ordered pairs. These are points on a graph. They could sometimes say find the x coordinate of the intersections, and then you would just give the x values. So just a reminder, second, trace, calculate, number 5, intersect is where we got all. You don't need to write all this down, but you might if you want just some notes. The minimal value of this new function k, which is f minus g, well, guess what? That's our y3 graph. So we could, I'm glad I didn't delete it. I just turned it off. We could turn these ones off just in case we need them later on, and turn this one on. So you can turn graphs on and off, and then they won't show up in your tables or on your graph if they're turned off, but they'll still be there. And you can still reference them with other functions and it'll work. Now the window, we could just graph it, but what this does is it's really the absolute value function minus 3, so it's shifted down 3. So it's this graph right here moved down 3 units. So it's just lower than before. And we're looking for the absolute min, which is the lowest point on the graph in the window. So should probably make our window go down maybe -5 so we can see it. There we go. So that's what we're looking for. Now calculator can do that for you. So I can calculate min number 3. You got to tell it where to look. Well, it looks like it's between 1 and 2. So 1, 2, guess 1.5. Doesn't need to be perfect guess, just something quick. The better it is, the quicker it finds it, but there's a point where it's not going to make a big difference. So now, if you look at what it gave me, it looks like the actual answer probably should be technically -3. But the calculator doesn't do things perfectly, and if you're using calculator to get your answer, then you need to write it like you got it from the calculator. So I'm going to say this is what I want you guys to do to get full credit. The minimal value is -2.999 or -3.000. Now, I would definitely put the 0 because if you just say -3.0, it kind of looks like you round to the nearest whole integer, whole number. So round or truncated at x equals 1.609. So I want you to put all of this, one or the other of these. You don't need both of those. That's why I want you to write absolute maximum answers. It's going to pay off, believe me. Okay? I know what's on the AP test. Now it says find the area in the first quadrant region enclosed by fx and gx. So enclosed means that it creates a closure and it's in the first quadrant. So I'm trying to find this area right here. Now we got to get creative because your calculator, when you do intervals, it only finds the area between a curve and the x-axis, which is not what we're looking for here. But what we could do is we could find the area under the first graph and then subtract the area under the next graph. This is what we could calculate, and then that would give us the area in between them, right? I don't think this is a bad idea, to write this down. So this is going to be gx, and this is going to be fx, and we're going to go from we need the intersections to know where to start and end it. Okay, so we got to use those intersections. So now on my calculator, what I'm going to do, and when you do integrals, I want you to show me the setup. Okay. The setup is like writing it like a calculus problem. So we're going to say 0.693147 to 2.079441. Carry a few extra decimal places in your work. If you don't, I'm taking off points. Do not round or truncate 3 decimal places in the middle of your work. That's why I wrote all those numbers up there. It was just in case, and here's my opportunity. Otherwise, I have to go back and recalculate and write all those extra digits down so I can be using that here. Now, we could do gx dx, right? And then we're going to subtract 0.693147 to 2.079441 of fx dx. Now, you really should write these dx's when you write this, okay? I'm going to get picky. And that should give us the answer, but we got to calculate. Now, here's the thing. I'm going to go back and turn these back on and turn that one off and go back to window and fix my window. Okay. Now we can only calculate the area under one graph at a time from the graph screen. And that's actually, we could do it quicker on the home screen in a second, but let's try it. Second, calculate number 7 and make sure you're on the right graph. Right now we're on the absolute value graph. Okay, which is the fx graph. So the way you choose the graph you want to do, and this is true for a lot of calculations on the graph, is you go up or down and you'll see it activates. It'll tell you which graph it's on. Okay, so make sure you do that. So we're doing that one, and then we're going to type the lower limit. You do that after you select that you want to integrate. Now you got to type the limits in. 693.147, enter 2.079441, enter, and it shades it in and it gives you the answer is 4.158882. Do not round or truncate it through decimal places yet. Now you're going to do the other one. The thing is that this region's shaded, so you're not going to be able to see it. The way you can get rid of that is you could go to the draw menu, second program draw, and say clear draw. And what it does is it regraphs it cleanly. Otherwise, the only other way to do that is change the window, and then that forces it to regraph it. So we can do second calculate number 7. Now I want to do the absolute value graph, and don't use this to select your lower upper limits. These need to be perfect. You can move the cursor for left bounds, right bounds, and guesses for other kinds of calculations, but limits need to be perfect. So we need to type it in. I mean, that looks really close, but it's going to be off enough for me to tell. So 0.693147, and then 2.079441. And there you go. Looks good. So that's going to be 2.2318618. And now I can go to my home screen and type these in and calculate 4.158882 minus 2.2318618. So I can type it in. And it should be positive, right? I mean, it shouldn't come out negative. Area should be negative, and that's your answer. Now, here's the creative way to do it. That would be quicker. And like I said, a lot of times we could go to the home screen and go to the math menu, math, and then near the bottom, number 9, F and int. Okay. Hit enter, brings you back to the home screen, F and int. And then what we could do is we could actually do multiple curves at a time. Like we could do this one minus this one inside the same integral. Or you could do them separately. Here, I'll show you 2 different ways. So we could do vars, y vars function. Y2 is the first one, comma x, comma 0.693147, comma 2.079441. So we could do that, and then minus math 9 and do the other one. Vars, y vars function, y1, comma x, comma 0.693147, comma 2.079441. And that should give us the same answer, all with one calculation, instead of having to do 2 separate ones, write them down, then redo it. Look, same answer, round truncated. Now here's an even slicker way. Do math 9, vars, y vars function, y2 minus, since they both have the same limits, we can actually integrate them together. We could do that, comma x, comma, and just do one integral, 0.693147, comma 2.079441. Do it one calculation. Which that's nice. It's thinking. And this bar is same answer. So anyways, just giving some different ideas of how to do this. And sometimes it's easy to do in the graph if you already have a graph, but there's no way for us to do both those calculations at the same time on the graph screen. So I feel like that was definitely a harder way of doing that on this one. Okay. So that's a warm-up. The rest of this, starting here and the whole back, is your homework. Draw sketches anytime you're drawing sketches. So do the homework yourself. The answers will be online, available online to check as you go. And then we'll go over the homework tomorrow. All right.